Okay, we have a 200-pound cable, and it's 100 feet long. So the weight of this is 100 feet. And we want to lift this to the top of the building. How much work is done? Okay, so this question is different and requires integration because a simple question of work is just you lift an object, right? And you carry a certain amount of distance, and it tells you, using a simple formula of work is force times by distance, you know how much work you've done. But this is not a one single object. It's like many objects attached to each other. And you can think of it as one small, right? That's a small object. We're gonna make that as small as possible by using limits. And we're gonna treat this as we have many of these little small weights attached to each other, and we're lifting all of these up. We're carrying a certain distance over for these objects. Of course, this one will travel not as much distance as this one, which will travel a lot more distance. Now this here tells you, okay, we're gonna assume that's uniform, the weight is distributed uniform. So 200 pound over 100 feet, which means this is 2 pound per feet. Okay, and let's assume this is our delta x. So the length of the cable is delta x. Okay, so that means the force for that delta x, so this length, we have times it by, so that's feet. You have to times it by 2 pound per feet. Okay, note that cancels out and we get the force. So it's 2 delta x. And we're concerned about how much of this, right, to what distance is it carried over to, okay, carried up to. So work would be, right, 2 delta x. So each one of these represents the force of 2 delta x. This first one here would travel, okay, let's start from here, okay? This one will just travel essentially nothing, right? And the next one, let's say that travels, let's say they're cut up into like 1 feet. So next one will travel, 1 feet. And the one after that will travel 2 feet, right? The next one will travel 2 feet, and so on. So in more general, we can write it as 2 delta x, right? Actually, we can write it as sigmas. 2 delta x I. And as delta x approaches 0, and these get really, really small, this is the same as the integral from 0 all the way to 100. Right, where that becomes 2x, delta x approaches dx, okay, infinitely small, and I actually becomes your x, your counter, right? So that's it. That's how we're going to find the total work done. So that's going to be 2x squared over 2, 0 to 100. So that cancels out. We get 100 squared. 10,000 feet per pound.